Hi guys, so in this lecture we're going to be looking at binary coded decimal, how to move from decimal to binary to BCD and to and fro. So just learning how to make the conversion. So binary coded decimal, or BCD, is a type of numbering system where each decimal bit is represented by a group of 4 bytes. So if I have the number 84 in base 10, then the number 8 will be represented by a group of 4 bits, and number 4 will be represented by a group of 4 bits. All right, so it's easy to know, to guess the length of the string, right? So the length of a number in BCD, so this is BCD, is going to be 4 times the length of the string in binary, okay? You may see being referred to as 8241 code, 8421 code, okay, or BCD. So that's how it works. Usually the first thing, or the best way to go about working with BCD, is to write a table for each binary number, for each decimal digit and its binary equivalents, okay? So this would be decimal, and this would be its binary equivalent. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, okay? So each single digit in decimal. So we need a group of 4 bits for each of these, right? And it will increase, incrementally as we add 1. This will be 1, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 3 ones. Okay, so this is 1, 0, 0, 0, and 1, 0, 0, 1. So this is what you have. This is a very important step when working to and from BCD. So now if I want to convert a number from decimal to binary coded decimal, so let's say I have 73 in base 10, right? So to convert this to BCD, all I have to do is look at my first digits and convert 7. So I go back to my table and I see that 7 is 0011. So that's 00, 0111. And then look at 3 and I see that 3 is 0011. 0011 in BCD. So that's really all there is to working to and from BCD. You pick each number in decimal, convert it to its equivalent, pick each number in decimal, convert it to its equivalent, and join them together in a single string, okay? So we can do this for as long as a decimal number as we like. 2349 would be 00, 0010, 3 would be 0011, 4 would be 0100, and 9 would be 1001. And this is in BCD. So BCD is a binary coded decimal. It's a binary code, meaning that it's not the same as the binary equivalent, because the binary equivalent for this would be, a really long number. But with this, you're able to tell easily what the number is in decimal. So that's one of the advantages of BCD. If I have a number like this, to convert this back to decimal, I just have to look at each group of 4s and convert that at a go. So I can see that this is 9. I can see that 0100 is 4. I can see that this would be 3. And I can see that this would be 2. Okay, so the main advantage of BCD is that it's easier to convert from the binary equivalent back to decimal. Okay, it's also important to note when you're converting to BCD that even though you're joining, so let's pick a number. Let's say we're working with 289 in decimal. I want to convert this to BCD. Remember, all we have to do is break each individual bit. So 2 will be 0010, 8 is going to be 1000, and 9 will be 1001. It's important when working with BCD that you have to add the padding of the bits in front of your first decimal digit to make sure that every number is attached to 4. Because if we dropped these two and we just worked with 1000, 1001, then these don't give a perfect multiple of 4. which is what is important when working with BCD. So if you're given a number and the task is to convert it to BCD, it usually helps to add the necessary zeros in front so that you're able to easily make the conversion. Okay? So another important thing to note too is that as a result of the nature of BCD, there are a couple of numbers that are not permitted to happen. So let's explore what that looks like. There are a couple of numbers that are not permitted. Okay, so let's do this way. So remember, we've drawn a table from 0 to 9, which is each individual bit in decimal. This is the decimal and this is the binary equivalent. If we were to do carry on from 10 to 15, what would that look like? So in regular binary, okay, so let's say we want to do 10, 11, and 12. So in regular binary, we know that 10 would just be 1, adding 1 to the binary equivalent of 9. So that would be 1, 0, 1, 0. 11 would be 1, 0, 1, 1. And 12 would be 1, 1, 0, 0. Which are absolutely correct. But once we're working with binary coded decimal, so let's say BCD, we know that since we have a 2-digit number, we need a BCD code is going to have 2 times 4, which is going to be 8 bits. So first of all, convert 1. So that'll be 0, 0, 0, 1. And then we convert 0, 0, 0, 0, 0. 11 will be in the same manner, 0, 0, 0, 1, 0, 0, 0, 0. 12 will also be in the same manner, 0, 0, 0, 1. Okay, 0, 0, 0, 1, 0, 0, 1, 0, and so on and so forth. So it's important to know that the rest of the binary digits, 13, 14, and 15. So that's 1, 1, 0, 1, 1, 1, 1, 0, and 1, 1, 1, 1. The rest of the binary digits from 10 to 15, that is after 9, are not permitted. They are not allowed when working with binary coded decimal because of the sole reason that the number of bits in BCD is going to be 4 times the number of digits in decimal. And since 10 to 15 have 2 digits each, 1 and 0, 1 and 2, 1 and 4, this is going to have to be 4 times 2, which is going to be 8. So we're expecting 8 bits when working with the numbers from 10 to 15, which is why these are not allowed. So it's important to note that when working with BCD, there are certain binary numbers that are not allowed. So that's all there is to working with binary coded decimal. You pick your, so let's work with 3483. You pick each digit and you convert it to its binary equivalent. So 0011, 0100, 1000, 0011, and then you join them together end on end and concatenate them. So that's really all there is. In the next video, we'll look at XS3 code, gray code, XS gray code, and other forms of binary coding. So thanks for watching, and I'll see you in the next video.